Here's an interesting guitar, tremolo, vibrato, whatever, reverb unit, standalone. The customer said it doesn't sound very good or work very well. I believe it is possibly a kit that might have been marketed by someone like Schematic, because they still do a kit that does just the reverb. I've got a picture of it here, and if you look at the top panel, it's extremely similar in appearance to this one. Same knobs, same sort of layout, same lamp. So I think it was from, they don't sell it anymore. I couldn't find anything about it on their site or anything. There's no circuit diagram. So I'm going to take it apart, check it all out, and get it to work properly. Also, you can see that the foot pedal is almost identical. It's got a single press and it's a double, so I'm pretty sure it's made by the same people. Inside, you've got lots of nice valves, 1, 2, 3, 4, 5. So it's going to obviously sound good eventually, and a nice big long reverb tank. So I think it's looking good. Now I think it's been put inside this custom made wood case, and it's the same as these custom wood cases that I have made by a guy in Ireland, probably made by the same person. You can see that the way it's been constructed with the dovetails, and there's another one here. You see all the dovetails, and the wood that's being used, and the curvature, even the handle was the same that was supplied originally with this handle. Now the front of this is got this sort of fabric. It's not the most attractive piece of fabric, and it is screwed from the back so it can be changed to another colour. This I've got like Guinness velvet on this one. Anyway, I'm going to take it apart, draw out the circuit diagram, see what's going on, and get it to work like a dream. After a little more searching around, I think this is a Weber Revibe. It looks, obviously the circuit is exactly the same, the layout. I don't know about inside. The valves look, layout 1, 2, 3, 4, 5 look the same. So I guess we're pretty close. If it is that, then luckily they do a circuit diagram. It's going to save a lot of time. Okay, we plug it in, turn it on. First of all, see what it's doing, if anything at all. So I've got a guitar plug. We've got the tone, max, mix. We'll put the mix halfway at the moment. Let's turn these things up, and you've got the. I think there's a bad connections on these switches. The problem lies with this foot switch. These pretty cheap things have failed changeover switches. They're supposed to short the pin to ground or open. These switches must be so cheaply made. It's hilarious. Look, this one works when it's like this. Switch in left and right, see the needle. Turn it up this way. Doesn't work. There must be something loose inside that is just flopping backwards and forwards. How rubbish is that? About the other one. This one again works that way. The other way up doesn't work. No wonder the person who owned this was baffled. Those switches look cheap. So cheap. Why save money on something just a few nothing instead of buying a decent switch? Oh God. 2 new foot switches fitted into the control, replacing these very poor faulty switches. These are not expensive. 3-pole ones, but rather using 1 pole. Just switching the earth on and off. This foot switch still wouldn't work even after I changed the faulty switches, and checking this cable, it's a very strange cable. It's got this sort of PTF wire. It's quite stiff, and I noticed that this PTF wire, or whatever it is, cracks very easily. If you bend it, you get it just cracks. And I kept checking this. It seemed to be a short circuit between the inner and outer, and it's not connected at the other end. And so I took it out of the clamp and moved it back, cut this back, and discovered it's completely pulled apart. It's either been badly kinked or pulled or stamped on or something, and it's just, or when they manufactured it, it's got a big gap there, and it was just shorting against the screen. This doesn't seem very good screen wire at all. I don't know if that would happen anymore later on. If you bend it, it just it should be flexible, but it tends to crack. That's really bad. Quite a long cable, so I don't know whether to use it or change it. Now the reverb works. And the mix control, which takes the reverb out of the equation. But not very loud. It cuts the volume through if you switch between a guitar, bypass this. This loses quite a lot of volume. If you boost the input, it just distorts like anything, which must be part of the problem with the circuit. I guess the reverb distorts if you put too much signal, and then they can't recover enough signal on this side, so they've had to cut the volume. Making some progress. I discovered that they had a wrong valve in this position here, which was not enough gain for the oscillator, and they also had these two round the wrong way, the 87 up here and the AX7 there. Anyway, let's see. That's full intensity. Speed. Could do with more depth, and the tone disconnects all the treble, but I mean the tone is a bit washed out anyway. I think that's partly due to the way the circuit works and have to compensate for it. It'd be nice to make this better. I guess they worked on it for years. I'm not going to say that anyone else can improve it, but I think I'll give it a go. It's fairly slow. Could probably make it go slower actually, but then if you make it go slower, then it normally goes, the top speed goes, but it's pretty fast at the top speed. So that'd be worth looking into. Yeah, could do with more intensity. The reverb's pretty good though. Not a great tone. Taking the electronic amp chassis out. It's only held in by a couple of screws for the top of the cabinet. And the one thing I'm going to do is shorten this excessively long Reverb Tank lead. It's quite low level on the way back, so it is screened, but it doesn't need to be that long, and it's only goes into a couple of phono plugs on this side. They've taken backs off them because there was no room in the cabinet. So they're pretty easily soldered on there. Just got to make sure you put them back in the right way round. It's marked red and white, but it's not marked red and white on the end, so I could do that. Looking at the chassis itself, it's got the mains transformer. It looks like it's got a tap on it for 110 volts as well. A little choke inductor, which is great, really keeps the noise down on the supply. Fancy blue capacitor, really nice. And the tiny little, this is like an output transformer, would normally drive a little speaker, but this is driving the tank, because the tank is an 8-ohm one, just like a speaker, and that's all it needed. A couple of connections. Now along here you can see all the valves, 1, 2, 3, 4, 5. I've put all AX7s, ECC83s in. I don't see the point of putting an 87. The AX7s, ECC83s always work better, unless the circuit is specifically designed for one of the other types of tubes. This would normally be used in a amp, 5 to say 8 watts, single-sided amp through the transformer to a speaker. It's a 6V6 or a 6K6. I've tried both. I couldn't tell the difference whatsoever in the sound, even though they have a slightly different specification regards the load and the plate resistance, all that sort of stuff. I could not tell any difference in the volume or the actual sound. Maybe because it goes through the reverb tank, and the reverb tank's not very hi-fi anyway. I mean, it messes the signal up quite a lot. But what I'm going to do is take the cabinet. I'm going to take this front off and replace it with some people might like this white. I don't think it suits what I want. I'm going to replace it with something darker, and perhaps even a grill. It's held inside, just been screwed together with some big wood screws. Then I'm going to take that wooden thing out the front. It's not a speaker cabinet, so it doesn't have to be totally resonance free or whatever. Still got a nice handle. Finish is okay. I got some aluminium grill, I think used on cars, full-size cars, and I cut it, managed to get the right size, just fit it in nicely, and secured it. Just the 4 screw holes were already there, just a couple of screws. So now I think it's going to look really nice with the amp inside, especially with the flashing bulb. I didn't think much of these 2 weedy screws which went through there and sunk into the wood to hold this whole thing on through those 2 slots there. Bit too weedy. Much better. Decent 6mm. Nice hex drive, countersunk. Will fit in there without sinking into the wood. Just got to drill it 6mm clearance. Still passes through the hole, and there's a bit of movement. So hopefully they're lined up pretty well, and I think they'll be much better. You can use a locking nut and washer. Much better, really secure now with the decent screws. I've also shortened these 2 leads to the reverb tank so that they're not all extra long, which you didn't need them. Nice and short, won't pick up noise as well. Keep them out the way. There's the back panel that will go on, and the fixed foot pedal, which caused me nothing but trouble with this unusual, very prone to, if you bend it, this inner cracks and shorts out. They just go into the plugs on the back, just in there. It's a bit confusing, they're not marked up, so I've marked them up. Vibe at the top and reverb at the bottom. And from the front, It's nice, you can see the amp there, and it's gonna, the valves you'll be able to see. This won't, if this rattles, I can always put a bit of rubber in it, which I've done before. Just stick a bit of rubber just in there. I'm going to talk about the Reverb, the circuit, and how it operates, and what modifications I've done. Now, the modifications I've done for my own satisfaction. It's not any criticism about the original circuit design or the operation, which is based on the original Fender designs, but just what I personally wanted to do, and to show you what can be done with the circuit. Now, this unit consists of a reverb and the so-called harmonic vibrato by that Fender designed way back in early, say, 1960. Now, this unit combines the reverb and the harmonic vibrato into one. Briefly, you've got the big long reverb tank in the back here, and the valves here, or tubes, uses solid state rectification. It's not a, it's an effect unit really. It doesn't drive, it's not an amp, it's got a speaker built in or nothing like that, even though it does have a 6v6 tube which could be used like in a small powered amplifier. And it's been built into this nice wooden case. It has a foot switch for turning the vibe on and off. As I said, this is a unit that apparently, from what I can gather, was put out, designed by someone called Jeff Gearing. This one from 2006, and the circuit is available online. I did find a couple of variations between this circuit and this unit. Not very significant, but a couple which I'll just go over. Now, I'm going to show you that it's in two parts, the reverb part and the harmonic vibe, or it's called in this case tremolo. Now, it's not a tremolo circuit. Tremolo is when the volume goes up and down. Vibrato is when the pitch goes up and down. And this circuit, as far as I know, designed by Fender, was called a harmonic vibrato because it switches the treble and bass sort of backwards and forwards, can create sort of a uni-vibe phasing effect. It's not actually a tremolo. The volume doesn't go down to nothing and back up again, which has certain advantages in that the sound from the guitar, whatever, remains about constant volume. It's not a heavy throbbing, pulsing sound. So let's have a look at this. This is the Fender Reverb. We'll go over that first. Fender Reverb Schematic, model 6G15. Pretty simple, and I'm going to show that this circuit, when incorporated into this double unit, they made a few, well, not errors, but I think they could have done a little better, which I've done in combining the two circuits together. Anyway, let's just go over this. There's a 6K6. In this one, 6K6, they also use a 6V6 and a 1287, which is a lower gain version of the 12AX7 or ECC83, depends where you are. And also they used a single tube here to recover the reverb amplifier and to combine the original guitar signal with a pot here. This was available as a standalone unit as well. That was available, and it's got another circuit here that's a bit smaller and a bit more difficult to see the details. It says here Fender Reverb schematic diagram, and it's got some extra figures on here. Can't quite see them probably, but that is a 6V6 and that was a 6K6 on that one. These are still 87s, and most of the other circuit parts are still the same, except for well, a couple of small things, but basically they're the same circuit. So we'll continue with this one. Now I'm just going over this so that you can see when I show you the combined unit what's happened. Just briefly, signal comes in. Now it's amplified and then it's cut down again with there's a 10-to-1 on the anode. They cut the signal, they amplify it, and then they cut it back down again. Then it's sent through what we would call a volume pot, which they call a dwell. In fact, they must have thought up a name for the drive on the Reverb Tank, because the rest of the signal, unaffected guitar signal, comes through here. Cathode follower, which is wasted a bit because it then goes into a rather high resistance pot, 250k, so the low output impedance here is then turned into a high output impedance, which is a bit of a waste. Reverb signal here off or on, maximum reverb coming down here, and you can swing this up to all reverb, all straight, or when it's in the middle, the two combined. So that is called a mixer. So quickly it goes through amplified, then they amplify it again and drive it into the 6K6. In fact, I did some tests and I found that this wasn't necessary, this stage here. If you don't cut that in 10x1 and go straight off the anode into a pot, you can actually drive the 6K6 quite easily for enough output to drive the Reverb Tank. But they wanted, they have 2 valves, so they decided to use it anyway, otherwise it'd be wasted. So you drive it in here, and this is like a little speaker output, 8 ohm input. That is just like a Class A. You could put a speaker on there and use a little amp. Anyway, it drives the reverb, the springs vibrate, comes back out here, can be shorted to ground with an on-off pedal, and then it's amplified by this valve here. Unusually large capacitor on the cathode. You don't really want to amplify very low frequencies out of here because you get rumble if there's any vibrations. You don't want to amplify them, so I don't know why they chose 250. I mean, 2 microfarads would have been enough, but who am I to criticize? Fed back out, reasonable 0.1 capacitor into the mixer, and it's also got a 0.01 down there, which I'm not quite sure why they bothered to do that. So when it's off, it's a bit odd. I just don't know. And a very, very small capacitor there. Maybe they were trying to cut the bass by using a very, very small capacitor there into there. If that switched to full treble, this might feed into a very high input impedance valve amp in those days. I guess they're trying to cut the bass, but why? I don't know why they amplified it so much in the first place. Anyway, that's that. The signal comes through combined. Pretty simple circuit. I guess they ended up putting it together and it worked fine. These days you wouldn't normally find in a tremolo, in a reverb circuit, an expensive power valve and transformer. They normally use a dual, a 1287 in parallel to get enough drive the Reverb Tank directly. But maybe that's what made the sound so good. I will mention that the reverb unit, as far as I know, they always used a long 2 spring unit, and 8 ohm input, about 2.2k output. And you could replace it by a 3 spring. This unit has kept the 2 spring one. You can buy a 3 3-spring one. I'm actually going to try a 3-spring one as well, which will give you a bit more reverb all round. So that is that part of the circuit, and I will show you that briefly on this combined unit. This is the reverb here. It comes in split 10 to 1, the drive amplified again, and a little split there, though I don't think in this unit they got the split. I think they just use 100k. That's only about 2 to 1 anyway. Drives into the 6K6 or 6V6 through the transformer into this 8 ohm spring out the spring. Again, they've just copied the Fender circuit, put a 250 microfarad in there, put these capacitors the same, mix control, and then this is where I think they missed off slightly what they could have done, and I do show you later. They mixed it in with the signal from the vibrato, so there's no actual unadulterated straight signal coming through. High output impedance, 220k, 220k, so you have to drive into a high input impedance, otherwise you'll lose a lot of signal definition, high frequencies and that. So that is a copy of the Fender Reverb that they used, almost exactly, except for the combination, which they didn't do. I will show you later that on my circuit. I'm not criticizing again Fender how they did it, but this is the cathode follower, which I think they just wasted. And I'll show you how you can use an anode follower and get a low impedance output. So that's that. Now the Fender, the Harmonic Vibrato part of this circuit. It was an unusual circuit, required a lot of tubes compared to normal tremolo. There's information available online of what amps it appeared in. They were all about 1960 to 65, so 61, 63, 64. And these are the ones that they say that you can find it in, from the Bandmaster Concert Pro, Showman, Super, Twin, Vibrasonic. Not necessarily all of them, because a lot of these change from beginning to end with the same name. So you'd have to, if you want to get one with this harmonic vibrato built in, you have to make sure you get the right year model, or look inside and find the circuit diagram, whatever the one that you're buying. There's a bit of description of how it works here as well, which I'll talk about later, which is pretty much spot on. It does mention there it sounds a bit like a Univibe, which it does. And why was it called what it's called? I agree with him. The guitar, a whammy bar as we call it now, it's not really a tremolo bar, it's more a pitch shift in vibrato bar, but yeah, all the naming of these parts got a bit mixed up. Anyway, moving on. You might think you're buying this harmonic vibrato if you buy a Vibro Champ, which seems to be the only one that has this name incorporated. In fact, the Vibro Champ is the only one that doesn't have the harmonic vibration circuit in it. In fact, the Vibro Champ has a fairly straightforward actual tremolo. If you look at this, you've got in the signal intensity being fed onto the cathode of this stage here, which varies the volume. It is a tremolo, and it just uses a single valve here, and varies the volume up and down with the intensity control on there. So it's not the vibro. If you think you're buying the Vibro Champ, going to get harmonic harmonic vibro effect or harmonic vibe, you won't. Interesting note also that the Bronco is identical circuit to the vibro champ, and again uses the same circuit here. So Bronco vibro champ, they are tremolos. Another one was where you'll find a tremolo but it's not the harmonic, is the Deluxe Reverb. It's got a vibrato channel, but it's not the harmonic vibrato. It feeds in, well, there's the reverb unit which I talked about earlier, and that is different. As you can see, I mentioned earlier, use a 1287, not a power valve. Go into it, and it's probably a much smaller transformer, reverb, etc., etc. Anyway, the vibrato channel down here uses an optical isolator, and that is fed into here, which is not a bias, doesn't change the bias. This is another sort. It's varying the volume by varying the resistance at this point here, which is taken, if we can see it, this vibrator channel amplified through here, comes in onto this valve here and fed round there and joins here, and it's got a volume adjustment up and down there from this circuit with the optical isolator. So that is another tremolo circuit, and it's not a harmonic vibe. So Fender had lots of different tremolo or vibrato tremolo. You don't know from what it marks on the front what you're getting exactly, so you have to do a bit of research. But some of them that did have this circuit, and another circuit that's slightly different, is a Fender Showman. Now the Showman is another version that I thought it came before, but it actually came after this original circuit. So the original circuit we look at is called the Fender Concert, was found on the Fender Concert. And I'll show you that a thing between this and the combined unit, where I've made some changes and they could have two. The signal came in here, was amplified and sent down to this point here, and then this is a phase splitter, and it's hard to see when you initially look at it. It just looks wondering what it's doing, because it's just the signal comes in as amplified from both sides and combined together. And this circuit is the one that's in this unit. This way it's combined here, and the way the vibrato is generated here is quite a complicated circuit. Uses one valve here, one valve there, just two valves. Later, and I thought it was before, but later for some reason Fender decided they didn't quite like that, and they changed it by there's the one valve, there's the second valve, and they've gone and added another valve here. But in fact it's only half a valve, because the other half of this valve is not even used in the Fender Showman. If you look at the chassis layout, you'll find this valve, which is two halves, two triads. One triad's not used, it's not got any connections to it at all. So they increased the cost by adding another valve, tube. I don't know why. I thought the other circuit looked fine. It works exactly the same by splitting the Well, I've got the input again, amplified here, coming in. This same arrangement here, where the signal is sent to both and combined on the output. And it's combined with the normal channel that comes around there. So I won't go over this one. This is a similar circuit, but I don't know why they changed it. Honestly, someone might explain it to me, but I haven't got one of these to compare the output sound. I thought that this was the original, and they condensed it down. We're getting rid of this tube, saving themselves on a tube, but apparently not. So, Fender Concert. This circuit is almost identical to what's used in this unit here, so we go with that. A quick explanation of how this rather complex circuit works. The signal comes in here and it splits one way and the other way, and you wonder what's going on there. But if you look at some of these components, you actually find that this capacitor takes all the treble out of this side and just passes the low frequencies, and this one, a very small capacitor here, only passes the high frequencies. So you've got treble coming through here, bass through there, and then you've got this oscillator circuit. I thought it's very well designed. It's got a null point here where if the gain is high, it's a feedback loop round there, and it's a unity of 1. It's very clever. If one side goes high, it increases this side, so it always keeps the gain of both sides identical. But out of phase, this is just reverses the phase from this. This is the frequency oscillator. This just reverses the phase 180 degrees. So when this one is going up, this one's going down, and they're exactly same amplitude. And so you've got the low frequency oscillations, and you've got high frequency and low frequency, and when low frequency is being amplified, the high frequency is being reduced, and then when high frequency is being amplified, low frequency is reduced, and you get this high low high low high low sort of effect, which is combined and fed out, and it gives you sort of the phasing effect. A couple of things to note here. There's a capacitor there, 0.01. It doesn't do anything. It doesn't cut the highs, doesn't cut the lows. And I thought it was because it was carried over from the original circuit, the Showman, which had a 0.01 there, helps cut the high frequencies and only passing the low frequencies through this way. The high frequencies in this drawing have gone that way round with a very, very small capacitor, only allowing them to go through. So I thought this came first, and when someone redid the circuit, they forgot to take that 0.01 out, and they left it in the circuit. But apparently it was the other way around, so it confused me a bit. I'm still not convinced that this one came before that one. I'm just not convinced. Anyway, that 0.01 does nothing, but the 0.005 cuts the treble, and this tiny 250 picofarad passes the treble. You got the bass that way, treble that way. On this circuit, you've just got the treble that way, the bass that way. They just got it reversed. Everything else is basically the same. 100k here, 4.7k, which I'll talk about later. A small capacitor there. It says 4 microfarads. Over here it says 2 microfarads. 4.7k, 100k, 100k. This is all balanced, 100, and they combine it through 2 470ks, and it goes off here, and it's combined going into the power section, combined with the signal coming up here. But notice that the signal is amplified and passed down there. Phew, that is virtually it, but I did find a little sketch someone done online. I didn't have to redo it, just in case you're still confused. There is the that sort of phase splitter. Here's the input signal. Very small capacitor, high frequencies. In this case, he's just got a 1 meg there, showing it as a reduces the, only allows the high frequencies through, and the signal also goes this way. High frequencies cut, just allowing the low frequencies through. And you can work out the frequencies: 636 Hertz, 144 Hertz. So it's fairly low, switching backwards and forwards. And the oscillator 0 and 180 combined there, so that it's a bit simpler for whoever drew this circuit out. It just helps you just see it. This is a bit simplified. There's a few extra more components thrown in, and in fact on this one, the high frequency coming down here is actually reduced the gain of it by 2. It's got 220k to 3, and I did check it out, and if you don't add that in there and pass all the high frequency through here, it the high frequency tends to be too bright and doesn't seem to phase properly. So I guess they found this by trial and error to reduce the treble a little bit. Some of this must have been trial and error, I'm not sure. But the rest of the circuit is about the same. So that's why that's got a 220k in there, as far as I can tell. That 0.01, not necessary. The voltage is all about the same. There's a lot of capacitors here that take away all the high frequency components, just keep shunting them all to ground, just to try and get the sine wave nice and clean and without any harmonics which would mess it up. So there's lots of shunting capacitors everywhere, lots of high resistances, speed pot, intensity pot. Now this circuit, now that I've explained all that, there's a couple of things I can show you that I decided to change for my own satisfaction. This has got the reverb section and it's got the harmonic vibe section. Well, he's just added the two together, and so he's got a amplification here, also amplification here. This, as far as I'm concerned, is unnecessary. Could you just tapped it straight off of that valve? It doesn't need this, which would free up, and it does free up, and I'll show you what I did with that valve. So that could be just freed up through there, because in the original circuit you can see it was tapped off anyway later in the circuit. Didn't have to have its own input, like so it could be, and I've tapped it off of here. This valve, as I said, and I did some tests, is not necessary. You can drive this quite satisfactory for any gain, but I didn't really have another use for that valve. If I wanted to do the other circuit that does have an extra valve that I showed you, I could have used it there, but it meant a complete rework of the entire circuit, and I wasn't going to do that. So that could be driven in through there. There is that, exactly the same circuit. That capacitor is not needed. That splits the high frequency gain by half. Lots of capacitors all over the place. And the speed, I've changed the speed, I've slowed it down a bit these days. Don't need very, very high speed, in my opinion. And as I said, it's got 250 microfarad there. It doesn't need such a high 250 microfarad. if you want a bit more gain, I think one of the circuits I looked at had 820 ohms there, which would be fine. And but I'm going to show you a couple of things I've changed. Right, and here's the circuit I ended up with. I've called it Reverb and Harmonic Vibe. And I'm just going to show you a couple of things. I'll do the tremolo, I'll do the reverb section first, then I'll do the vibe section. Looking at the reverb section, I put a 10k resistor on the grid. It helps cut radio interference, especially if you just come straight in without a resistor, which they used to do in the early days. They didn't have a lot of taxes and a lot of extra signals from radios and things all over the place that didn't used to pick it up. But now a 10k, a lot of amps you see use 47k. 10k is enough. 1 meg there. So I put that in. Didn't change anything there, but there you can see I've tapped off through a 0.01. I've tapped that off and taken it down to the harmonic vibe circuit. So I've managed to do, there was the original circuit had used the whole valve, half a valve to do that. Done away with that, and it's fine. I mean, plenty of signal. I've taken the full signal there, didn't need to cut it down. I've kept this circuit here because I wasn't going to use this half a valve on anything anyway, and I'm going to show you how it's become useful later on. Coming up through here, I put a 10k on the grid of this. It helps with stability on the grid anyway, right on the grid. You may not want to put it on, but I did. I didn't change any of these. I didn't put an extra gain capacitor on there. There's plenty of gain through here. In fact, more than enough gain. And I'll show you what I've done on the Spring in a second. I'll just do the output. Reverb switch cuts on and off here. Note that that cable, screen cable, is 450 picofarad. So really, when it's working, it's got quite a high frequency cut off through there to ground. Anyway, 220k, not entirely necessary because this is a 2.2k, which is connected to ground anyway, which is a grid leak. But they put it in anyway. I suppose, I don't think it's necessary, but I put it in anyway. 1.5k's. And I've taken that down to 10 microfarad. You could actually go down to 2 microfarad. 250 microfarad is just, I thought it was just mad. That could be 820 ohms if you want a bit more gain. 100k, kept that. And I've used the mix control here, 500k, so it doesn't load up this output at all. Now the original one came through a tone control. Well, I don't see the point of having a tone control on the reverb. You can cut the treble, bass, I guess. I decided to do away with the tone control on the reverb and use it somewhere else. And use the mix control there. And just feed it straight into the mix control. And I'll show you what I did with the tone control later. There's the mix control. And now I've also got an output taken from this point down here, which is the guitar signal that doesn't go through the vibrato. And here is that valve that was at the front end. I've now moved it to the back. and I've made an anode follower. It's like a cathode follower, but the output comes off the anode. You might think that that's not a good idea, but in fact with this feedback arrangement, this is very low output impedance, only about 1 to 2 kilo ohms, and it can and it's not loaded down by an output. And I used that 50k pot that was the tone control. I've now made it the output volume control, and you can see the output resistance is now only anywhere 50k. Very nice low output. Drive any input or long lines without any loss of high frequencies or whatever. Much better. I just put a 4K7 in there just so that if this was shorted out, you didn't short this right to ground. Not totally necessary, but I thought I'd put it in anyway. And that's an anode follower. I put a 10μ in there. I think the original circuit over here didn't have a capacitor, but I put it in anyway. I put it in now, which you need on the anode follower. And so this has got a nice high input impedance, and it's a mixer basically, so I can mix all 3 circuits together now. I can mix the reverb, the straight signal, and the vibro here. And I've put an on-off switch, so you can actually switch the vibro off totally. And I've put that on a pull switch. I'll show you that inside. Not totally necessary, but a lot of people think that the guitar sound is changed going through this circuit, which it is a little bit. So if you just want the guitar signal, you can now have it, which you couldn't on the original unit, because if you turn the reverb down to 0 and open this up, you've just got the guitar coming through here from this circuit here, and now you've got something extra which the original didn't have. Is you've now got a gain section here for the guitar. You can put the guitar in here and use the dwell control as a overdrive. So the signal's here, you can turn it up, get lots of peak signal amplification through here, feed it down here, and get a really powerful, almost a distorted or well overdriven sort of signal through here to the output, just the volume to suit whatever you're driving. And you can use it as a booster for your guitar. No tone controls, you can do all that with your guitar or whatever. It's a straight boost, and it was easy to do. Hardly any extra components at all. Just a few, couple here, a couple of 1 megs. You choose 1 meg. It's got 1 meg feedback, 1 meg inputs. There's a 1-to-1 gain. Virtually no distortion added here. Just very low output impedance. 1-to-1. You can adjust these slightly up if you want a bit more gain. Say from the reverb, you could lower that. It gives it a bit more gain, but you can only go so far. And that works really well. When you've got the reverb in, full reverb, you can adjust the amount of drive through the circuit with the dwell control. And you can adjust the 2 of them to get a nice mix of the reverb with the guitar. You get a really nice reverb sound. Before, you only had the reverb and you had to mix it in with the vibe channel. So it's getting pretty comprehensive already without even hardly any extra components whatsoever. I'll just add a little bit more about the Reverb Circuit. This is a 2-spring long, 8 ohm in. You can get a 3-spring one if you want and put it in there, which give you a different sound. You can buy them. Some of them are quite cheap these days. One's made in China or Korea. Anyway, this is a 2-spring one, driven here. Now, if you drive these tanks too hard, you can bang there's a magnet that vibrates in a coil that shakes the spring, and eventually it hit the end stops. It can only go so far, and then that is not good. You'll get unwanted sounds and distortions and all sorts of things. So you shouldn't overdrive the input only up to a certain maximum. And because I've got quite a lot of grain through here, I added peak limiting to stop overdriving of here. How does it work? Well, this bulb normally is a very low resistance, so the signal drives it like normal. But as the signal increases higher and higher, it will eventually start driving this bulb, and as soon as its bulb starts lighting up, it goes high resistance, which limits the signal on peaks. It stops you overdriving the spring. I put it in parallel with, I worked out a 33 ohm. Sounds pretty high, but it actually works out fine. When the bulb's fully alight, you've got a 33 ohms in series with the 8 ohms, and it still gives you a good output. And if this bulb blows, it'll still work. If you didn't have the resistor, it would go dead. I'll show you that working later. It works really well. The Harmonic Vibe circuit. Done a few changes. As I said, the input here doesn't need its own input. I've tapped it off of there. I did fiddle around with the output to make these the same, so one's not louder than the other, and they came out really well actually. These two, and this one was a bit loud. I'll show you why in a second. This output here just needs to be cut down. There was already some resistor positions on the original circuit here. On the original circuit, they had to cut this output a lot, 330 to 10k, right down, because this output was much too high compared to that one. 330, 10k, 220s all combined through there. I found that I only had to cut it a little bit, 330 to 100k, and then mix it through a 1 meg, and the levels are fine. Now the advantage also of this now is that the original circuit only had about a 1-to-1 gain, so you could only get about the same output as the input. There was no additional gain available at all. With this one, there's lots of gain available now, and I'll show you that it's you can really get a high output here and drive the next stage. Or if you turn down the input quite low, with not very nice clean sound, no distortion whatsoever, you've still got enough output to get a decent output. Didn't have to change the power supply at all. Solid state anyway. Let's look at the circuit. So the output comes out here, input signal comes in here, divided. I take that capacitor out, doesn't do anything. There's the high frequency cut, so you just got low frequencies. There's the high frequency pass through there, high frequencies there. Phase reversal from 0 to 180 for this side. The vibrato oscillation circuit here, I slowed it down. It's pretty easy to do. You can slow it down quite a way before it stops working. I increased the value of this capacitor from 0.01 to 0.02. I changed this from 1 meg to 2 meg. Changed this one from 1 meg to 2 meg, and I found that was enough to get a frequency of about 2.5 to 8. You only get about 1 to 3 variation on these circuits anyway. These capacitors I mentioned before, there's lots of them. They cut the high frequencies out, try and make a good sine wave. I made this capacitor a bit smaller, just to get a bit better low frequency, well, kind of throb. I messed around with these capacitors, but it did make a difference. By the way, these, I use a 12AX7 there, ECC83, not a 12AT7. They used the AT7 originally, so that because there was too much gain here, they didn't need it all, as I mentioned earlier. And if you use a 12AX7 there, you could have done away with that one. I did one other mod here. This is a 4K7 on all the circuits I've seen, but when I looked at the oscilloscope of the frequencies, I found this was pretty, using 100Ks there, it was a bit offset. the bias was way off, meaning that the signal was asymmetric. It was amplified a lot up one way and not much down the other way, and at high levels it sounded a bit distorted, actually quite a lot distorted. And I discovered that by lowering this 2K, maybe even down to 1K, but I ended up with 2K, the signal cleaned up much better without distortion. I don't know how they arrived at the other figure. I'm just saying I did this for my own satisfaction and not criticising the original design. I've got a nice output signal and can turn it on and off. I think that just about covers all the mods I did. Doesn't look like much, but it did take a bit of fiddling around with, and it's turned out really well. I'll just show you inside. I just had to make a small mod over here. Is where using this valve, the V1 that was in there originally, and it's now over here, V1A, V1B. That's the V1's right down there, and that is the summing circuit there. I've got this capacitor was already there. Added a 1 meg. I've got a cable here and I've summed all the 3 1 megs here. You can just see them, 1, 2, 3. That's okay, it's not going to vibrate. There's some down to there, straight into the grid, which has also got that 1 meg feedback via this capacitor, and that's taken out to the output. Well, here I put a 10K on the grid of that V6. Some people might not think it's necessary. On the input, which comes from the middle of the amp here, I've got a 10K just soldered to the grid there as well. This section is the vibration oscillation. I've added a couple of resistors, just put one on there, pretty straightforward. And I added an extra capacitor there, just doubled that one up. This capacitor here, I put it in series with another one for the low frequency effect. I found that reducing that added a bit better low frequency throb. If you don't like that, you don't have to do that. Everything else, here's the pull switch on the back of this, pulls, which it's on the dwell control. It just cuts off the vibrato if you don't want it, and then you can use the dwell control to drive the original signal from the guitar without going through the vibrato circuit. Mix controls for the reverb, adding reverb in. Tone controllers become the output volume, which is really good because it's right next to the output, so it's all come out really nice. Intensity, speed controls are the same. There is the 33 ohm. I wired it there, and the bulb is there. I put it in a little bulb holder. There was already a hole in the chassis, so I could just put the wires through to the back of the bulb. And if it blows, you can just unscrew the bulb and put a new one in. I experimented with the bulbs and the circuit that I have, and a 2.5 volt 0.2 amp was perfect. Others give different overload effects. If you go too low, the bulb, if you're not careful, you can blow it. If you go below 200 milliamps. Over here you've got the connections from the foot pedal. As I said, this screen lead's got 450 picofarads. It's quite long, screen lead all the way down to the foot pedal. There was a small error on the original circuit. Nothing really. They show the foot pedal connection to that point for turning the vibrato on and off. I thought that doesn't look right. It shouldn't be there. Why they put it there? Anyway, I checked. They've got it in the right place, which is there. So they made a mistake on the circuit diagram because they have got it wired in the right place. When it's there, when you turn it on and off, it kicks this valve with a voltage pulse, which makes the oscillation start. Otherwise, sometimes it takes a while to get going if you don't do that. Also they got 220k smart, and they actually used 100k's, which the other circuits do. They might have tried 220k because of what I said, but the circuit being slightly asymmetric when you're driving it, to try and get the signal a bit more symmetrical. But they use 100k in the end anyway. Another thing I've adjusted on this amp is this this phase splitter arrangement here. Now they originally had 220k, but in this amp they've changed to 100k. And on this drawing I got from a Fender amp, they do show 100k there. But I reckon this 4K7 is too large for 100k, and I can show you that by lowering it you get a much better signal, high voltage signal, before distortion sets in. I'll just show you. Now here we've got about a 1 kilohertz signal. The yellow one is the output measured here. It's the actual output. I've got probes there and there. Now on the resistor across the cathode, which I was just talking about, this is the original signal. You can see that it's just beginning to distort. If I turn it up a bit, it's distorting badly now. Now if I switch in a resistor in parallel with this one, taking it down to about 1.8k, I'll show you what happens to the signal. I've got a little switch here, and I've got the resistor onto a resistor there, which obviously switched into parallel. Just going to switch it in now, and you can see besides the signal increasing, it's cleaned it up a lot. Let's switch it back out, and with the resistors in parallel, you see the gain increases, but the shape of the signal is better too, considering that that's maximum I'm talking about. If I lower it down, it's starting to go out of shape. Put the resistor back in. Now that's at let's take it out again. Let's do it at, that's at 1 kilohertz. I'll take this down to 100 hertz and then parallel up the resistor. Much better signal. And at let's go up high frequency, 10 kilohertz. If I switch in the resistor, that's a better signal. Some people say this this split thing here, which does the bass on frequencies, lower frequencies and high frequencies, and recombines them, it does affect the frequency response. When the tremolo is off, the signal passing through is a combined signal, so you do get a slight variation in frequency response, but not too bad. This 10 kilohertz signal right there, turn this down to 1 kilohertz, a little bit increase in gain, and 100 hertz. So there's not much variation, tiny bit of increase at 1 kilohertz, which is, it's not bad, but if I sweep it across, it doesn't, as the lower frequencies come in, it starts to lose gain. That's only at 40 hertz now, so what you expect that. So it's not too bad. But anyway, changing the resistor to about 1.8 kilo ohms, in my opinion, enables this signal to be less distorted at high signal levels, and of course at low signal levels with peaks, even less distortion. I can just demonstrate the effect of the vibrato tremolo signal on the incoming signal. So the yellow is about 5 kilohertz. That's the actual signal going in. And if I turn up put the speed down low, intensity on 0, if I start turning up the intensity of the tremolo, you can see that signal is going from loud to soft. Doesn't completely go off. Just turn that down. If I turn the frequency up, so that's at high frequency. So let's try that low frequency. I just turn it off. Turn the frequency to try 400 Hertz. Not much of a variation showing up. Increase the speed. No. 400 Hertz. 100. So at 100 Hertz, it's having quite an effect. 1 kilohertz, 10 kilohertz. So that's how how it affects it. So it's the treble and the bass are going up in alternately. Just a quick look at the Reverb Tank if you've not looked inside one before. This is a pretty long one. I'm not sure if you can get them any longer. I think this is the maximum length. It's an 8 ohm input. You can get higher input impedances for transistor drivers, etc. This is for a valve driver, fairly high output impedance, which is fine, will work virtually into anything. 3 springs suspended on this center mount is suspended on springs from the side, and it floats in the air. It's got some little rubber buffers that stop it when you're carrying it, I guess, just to stop it slamming around. Now they're made to either be mounted flat like that when the thing's in use and it hangs down. It'll hang down from the mounts, and some are made to be mounted on the side, and they've got a different mount so that it doesn't rest on these sort of stops. So you buy one depending on whether you're going to be mounting it flat. And also you have to be careful, you can't mount this flat one upside down because the weight of it rests on the bottom and it won't work. It's suspended only when it's this way round. It hangs down and you probably can't see it, it floats. The springs, these transducers are little coils, and they, when you energize them, there's some little magnet that pulls the magnets backwards and forwards and vibrates these springs. They're a bit delicate, they're held in tubes so they don't touch anything, they're suspended in the middle of tubes and so they can vibrate. Now if you increase the input level sufficiently, the magnets will hit the end stops, and then you'll get spikes. You may not hear them, but it will give you distortion if you keep banging them, overdriving it. The output you can't really overdrive. So it's pretty simple. It's a mechanical thing, it can be broken if you slam it around and bang it or bend it or just mistreat it. But there's not much to it. So this is a 3-string one. The 2-string one's exactly the same, just has 2 springs. But they do sound different. Maybe it's the quality of the parts, maybe it's the tension of the springs, or whatever the spring's made of. There's not much in it, but it was a clever original mechanical design, now all done of course digitally or by some electronic means. The original still sounds excellent. Quick note about the Reverb Tanks. In here there's the Accutronics 2-spring big long reverb tank, low impedance front end, about I think they quote 8 ohms, and a high impedance output, and that is a 2-spring Accutronics. Now there are lots of replacement makes of reverb tanks you can get, and this one here, this black one, is a 3-spring version, It's exactly the same specification, 8 ohm input, high impedance output, and so you would think it'd be better. Now online you can get some information about reverb tanks and some tests that people have done. I'm not sure who did this, sources, anyway you can find it, and they speak of the different makes, where they're made. I'm not sure, Acrotonics USA no longer in production, so I'm not sure if this is an original one or not. Anyway, the codes are written on them, and it explains how you can decipher the codes, and it tells you all about it. So it's a 2-spring one in there, and this is a 3-spring one. I thought I'd try it and see what difference it makes. Now, according to the information, when they did a test, they tested 2-spring versus 3-spring. It will change the sound characteristics of the reverb effect. 3-spring tanks have a more smoothed out flutter with a bigger, fuller sound and reverb effect and more lows. 2-spring tanks have more flutter and grit, and they also seem to capture that vintage 65 better. So I thought, well, we'll give the 3-spring one a go. The only one I could find was this made by MOX. They're very simple inside. I'll turn it over for you in a minute. There's not much they can do to mess it up, really. The spring's stretched out between the input transducer, which is a coil and magnets that vibrates the spring, and then pick up the other side. There's nothing special about it, so you'd think they'd be fine. So what I've done is I coupled them up here with a switch, so I can switch between the 2-spring and the 3-spring and just see what the difference is. I've disabled out of the circuit the straight guitar sound, so it's just the reverb only, and I've turned the reverb up to max. It's a bit hard to tell the differences, but see what you think, this sort of effect. So you might be able to hear it decaying. Just decayed away there. I can hear it just decaying away there. Switch to the other tank. With that position, the decay is noticeably longer. Now when you listen to the sound, it's not so easy to tell, so you've got try the other one. With that one again, it decays much quicker, and it's noticeable on those chords as well. As far as the flutter goes, I don't know how you can tell that, but individual that's got a far better almost echo quality, and again in that position that is down, so it's got longer, better sort of echo effect. Bass, treble, well, the frequency response seems the same, but there's a huge difference in that position down. It's much longer, a better even echo effect. And so which one is it? Well, let me see. So that's in the down position. This is the tank up top. So let's unplug the black one and see what happens. I've unplugged the back one, and the reverb's still on. So that's the original Accutronics tank. Is easily, noticeably better than this replacement 3-spring one, and that Accutronics is a 2-spring one. This is a 3, but the length of decay and the echo response is far superior. May not show up on here, but it's really noticeable. Of course, when you're mixing it in as just a reverb, you probably, I don't think you end up telling the difference, because this is quite a severe test. But it's interesting that that 3-spring replacement one is not as good as the original one if you really are going to be fussy. I'm going to add a bypass switch to take out the whole of the vibrato circuit, because it adds some distortion when it's turned off. So I'm going to add a pull switch just to take it out of circuit and to allow the unchanged guitar signal to pass through from input output, but it will be adjusted by the volume control and still be able to mix in the reverb. So I'm going to use this pot and swap it out with the dwell control. I believe is I've got a 470k log. The dwell control is 250k, but that'll be fine. It's the only one I could find that has that was a pull switch, and it's got a proper full size nail on it. Some of them are small diameter, these pull switches. I did another small variation on the circuit, made it a little bit better again, regarding this add-on I put on the end, which mixes in the straight guitar signal, the reverb signal, the vibe signal, all into this little mixer and drive out. I've now put, because this pull switch I had two on-offs on it. It was made for mains on-off really, but it works just as fine. So now when you have the reverb and the vibrato switched in, I switch out the straight signal that came in through there now, so that it doesn't dilute the sound you're trying to get. For instance, if you want maximum effect from here, you don't want any straight signal also added in diluting it. So and you can turn the whole reverb off here. When you pull this on, that goes down, and this, luckily all these points, I didn't have to add any extra circuit, it just shorts out this point to ground, which does not affect the signal mixing point here at all. There's a 1 meg there, and it just shorts this signal to ground, and it closes that switch and passes the straight signal through, which is able to be boosted from the dwell control. And then when you switch this vibrato in, it opens that switch, doesn't short it out, but also opens that one and stops the normal signal coming through, and it gives you a proper depth now on the vibrato. Did mention the bulb up here on this circuit here. You might notice that when the signal gets high, bulb goes high, the resistance on this transformer goes quite high, and you'd think that would pass back too much impedance to this valve, causing a high voltage on this side of the transformer. Doesn't seem to have any effect. I did try some other values. If you don't like it, I didn't find any problem at all. The sound is definitely better with this in. I didn't do that in the video, but I did do some tests with the oscilloscope and listening, and it definitely sounds better by limiting the peaks going into the reverb. You can use different bulbs. 2.5 volt I use a 0.2 amp. They can blow, so I use a 0.3 amp now, but you can, it just screws in. So that's that little mod there. Everything else I didn't bother changing. You can use a 1287 at the front if you want, or 12AX7, no 25, ECC83, EC82. It does change the sound a little bit, but I prefer the high gain ones. Besides that, I think I explained everything else I did on the circuit. You can change these capacitors if you want, but you don't have to. They can cut out high frequencies and low frequencies coming out of the reverb if you want, but it's not essential. But this works absolutely perfectly, and the sound I think is now spot on. Quick look at some of the mods just before I close it up. What I did, there's the resistor that goes off to the bulb, which I've screwed a little bulb hole in and changed the bulb, take it out during you want it. There was a hole in the back of the chassis and a couple of screw holes already to hold it on, so that didn't take too much. The mixing on this valve here is done with a few extra components using the capacitor was already there, and that point ended up being there. Just had to stretch a resistor over there, a little 10k on there, just coming off of there, nothing awkward. I did all the mixing here, the 3 inputs on 3.1 megs on there. They're nice and rigid, it's not going to fall off. Use some screen leads just to stop any noise pickup. And that's the other 1 meg resistor, they're part of the circuit. And the switch I put in here, the pull switch, is had 2 poles on the back. It was a mains on off, so they were just closed, both closed or both open. It worked out absolutely perfectly what I wanted to do. Just taking it off there. Just had to rearrange this capacitor slightly and take a feed off of there. No big deal. I did put a 10k on there, just got to heat shrink that on there. I reduced the value of that capacitor, so I explained, to get a better deep end. Also, some of these capacitors increase the depth quite a lot, but I found that was about just right for me. To reduce that capacitor, I just put one in series, wasn't too difficult. A couple of components added, 1 meg there, 1 meg there. I added another capacitor in parallel there. And I think I changed the capacitor on the, I didn't mention it, but the cathode resistor for this big valve, when you turn it on, when it hasn't been used, you get quite a high voltage coming through. The voltage of the cap used originally was only 25 volts. Even Fender used a high voltage capacitor at this point, and you need at least 63 volts. They even use a Zener on their later circuits of 50 odd volts to stop you get a high voltage on this point until the valve heats up. So I put 63 volt one in there so it doesn't fail. Shorten the wires to that super tank. It is made in USA. You can't see it, it's written on there, Accutronics, which is really great. I didn't do this. This was done by whoever originally made it. Solid state. They didn't have anywhere to put it. That's how they did it. A bit messy, but I left it like that. Nice capacitors and everything else. I did try 6v6 and 6k6. Didn't notice any difference at all. I did mess around with these valves from high gain to 87s. Again, very little difference. I used the high gain ones. And that's about it. It sounds absolutely fantastic now. Just got to put the back on. Circuit's finished. A few mods I've done just to suit what I want it to sound like. And this is the sound through I've got a little valve amp from a record player up here through a speaker. and this just switches backwards and forwards to the guitar or through the effects. So the volume is about the same. That was straight through. With the mod I've done, straight through, and you can, so the guitar, then I can turn the volume up. So it shows you the volume boost you can get. And then with this controller I can reduce the gain, turn up the if I boost the actual gain right up, which boosts the gain through the whole front end, it's turn down the volume. So lots of drive there, so you can turn that down and then set it. To the amount of drive you want. That's quite comprehensive now. That's an effect that it wasn't available before. And the Reverb Vibrato is out of circuit. I can add some reverb. And add to the straight guitar sound some reverb. Maximum. Reverb, turn it back a bit, and that can be used for this sort of thing. Turn off the reverb, put the dwell, pull the dwell out, so we now do the vibrato. Speed maximum, intensity about half. Turn the speed down. Less intensity. More intensity. Slow it down. Then you can add in the reverb. Turn off the vibrato. Turn off the reverb. Front of the amp, it's got a see-through grill and controls on the top, obviously. So you can see the bulb flashing. It's on full drive at the moment. No reverb, I think. Reverb on. Loads of reverb. Turn the reverb down a bit, which is that one. Turn the reverb off. Now with the vibrato, I can turn that on. Turn the reverb off. More reverb. Treble. loads of reverb. Reverb off, vibe on, vibe on. Vibe off. Hit the full power. Treble, that is. Take a bit of the treble off. That's a really nice sound. Bit even more bass. Add some reverb, not too much. Take that off. Put the vibe back on. So with a bit of extra So that's it finished, came up pretty good indeed. Great range of sounds. And the overdrive sounds a real bonus, sounds excellent. I like the see-through effect. It's easy to change, no one likes it. See the flashing light, everything works great. Low background noise, nice range of controls on the control panel, everything working. Super.